All right, let's get started. First things first, my name is Mario Sanchez, and I run training here at Sumo Logic. But more importantly, we have Olaf Stein, and Olaf is part of our professional services team. He's part of customer success, and Olaf has run through multiple deployments. He's helped many of our customers. So not only is he well versed in how to do things, how to set up your Sumo Logic environment, he's also very knowledgeable on the best practices. So today we're going to talk about data collection. We're going to talk about system optimization. And throughout this session, Olaf will walk you through both how to do it and as well as best practices. And bring questions up if you can. I'm going to try to monitor the questions tab as we go through it. But if not, we certainly will have time for questions at the end. So before I turn it over to Olaf, I just want to run through a quick agenda here. So at the completion of this session, you will be able to, one, deploy the data collection strategy that best fits your environment. So you're going to have multiple sources. We're going to talk about the different data collection strategies, and you can start seeing what matches your environment, even if it's a hybrid strategy from the ones that we show you. The other thing is we're going to talk about best practices around data collection. We're going to talk about how to develop a robust naming convention. And this is very important because your users are going to be searching using this metadata. So coming up with a naming convention for your metadata, it's going to be a huge help if you do it correctly right from the start. Just so that we can verify data ingest, we're going to run through some simple searches. This session in particular is not focused on searching. There's future sessions, and I'll talk about that in just a little bit. But we're going to just get you there at the beginning so you can verify your data ingest. And last but certainly not least, we're going to walk you through how to utilize some of the optimization tools that we have, and so how you can start using these leverages so you can enhance your search performance in your environment. So, because I saw from your answers to the polls that most of you are fairly new to Sumo Logic, I thought I'd start with the 30,000-foot view with what is Sumo Logic. In short, Sumo Logic is a tool that is going to allow you to make sense out of the complex data that your system is providing you, or the data that your complex system is providing. And most of you are using at least one of these three use cases. Perhaps you're using Sumo Logic for DevOps, and in that case, we want you to spend more time developing and less time troubleshooting. So we help you to troubleshoot and identify bugs through the logs so you can focus on your development. Perhaps you're also using it for IT infrastructure. In that case, we help you monitor your entire stack and identify those things that are important to you, whether it's network latency or some performance metrics. And the last use case is for compliance and security, the ability to keep an eye on your environment and make sure that you're in compliance through what we call our threat intelligence analytics in here. So what kind of data can we load into Sumo Logic? In short, we can load just about anything, whether it's structured or unstructured data. These are some of the environments some of the sources that we can grab data from. All these generate logs that we can ingest into Sumo Logic. The left-hand side here could represent your stack from your network, your virtual environments, your databases, all the way up to your custom application code. Your right-hand side could be the infrastructure of your environment. So again, this is just a snapshot of some of them, but just keep in mind that we can ingest any kind of logs, whether it's structured data or unstructured data. So at a high level data, this is the three main areas that happen that we do with Sumo Logic. We collect data into Sumo, and this is where we're going to be spending the next 2 hours, getting the data into Sumo Logic through collectors and sources. But once you get that data into Sumo, then we show you how to search it, how to analyze it, and using operators to identify the trends, to detect anomalies, whatever it is that you want to analyze with that data. And last but not least, we help you monitor and visualize that data. So I just want to bring something up to your attention. From these three different steps that you're seeing here, we have different courses. So today you're attending this one here called Setting Up Sumo Logic. By the way, I'm at sumologic.com/training, which probably most of you used to register to this webinar. Just keep in mind that this is how to set it up. If you want to learn how to do steps number 2 and 3, these are courses that we offer through the Sumo Logic Quick Start and the Using Sumo Logic. So if you once you get your environment set up, you definitely want to join one of these these sessions or these two sessions and start pushing your users to these sessions so they can start using the data that you ingested into Sumo Logic. All right. With that said, what I want to do now is I'm going to turn it over to Olaf, make him the presenter, and he will start walking us through through the agenda that I just talked to you about. Olaf, are you on the call? Olaf, we cannot hear you just yet, so you might want to put yourself off of mute. Actually, maybe I have the controls for that. Give me just a second. Let me see if that's the case. 1 second. Attendees, here we go. Olaf, if unmute. Okay, Olaf, are you there? Olaf, we cannot hear you if you are speaking, so just make sure you put yourself off of mute.
Oh, here we go. You hear me now?
Excellent. We hear you, Olaf. Thank you.
All right. So I don't know. It wasn't letting me unmute myself. So, all right. Let me share my screen here. You guys should be seeing a slide. Can somebody confirm that that's the case? All right. All right. So welcome. My name is Olaf. I work on our professional services team, and I'll be walking you through the agenda that Mario outlined. Predominantly, this session, as Mario already said, is about setting up your data collection, find the right strategy, both in terms of the collection itself, as well as the metadata, and because that sets the tone for the rest of your Sumo Logic usage, both in terms of searching the data as well as using some of the optimization tools that will help you with both performance and adoption at the end of the day. So we're trying to make sure that, you know, after this session, you guys have a good idea of how to set up Sumo for your specific environment. Unfortunately, this is not a one-size-fits-all approach, because very different people do very different things with their data and have, you know, different objectives. So we want to make sure that you guys set up your environment to match your specific needs. Let me put this in presenter mode here. And as Mario said, if you guys have any questions, please please put them in the questions tab, and we can also unmute at the end to ask questions in person, and do so at any time. There's no need to wait till the end or anything like that. I'm happy to try and make this interactive if possible. So I will put this in presenter view here. Oops. Now we go. All right. So this is the first session, setting up Sumo Logic. The first item I want to talk about is the data collection strategy that you guys may employ. Let me go to the next slide. So here you can see we're obviously hosted in the cloud, right? We were born and live in AWS. It's a managed service, basically, and we manage this infrastructure for you. All you need to do is send us your data and then do something with it. That adds the complexity that this data that you guys are generating in various locations. This could be in the cloud if you're using the cloud. This could be in your on-premise data centers. It could be both, right? And that data needs to get to us, to our backend first before we can use it. And on a very high level, there are 3 different paradigms. Actually, there's only 2 different paradigms that people employ to get data to us. The first one, we'll talk about these in more detail here in a minute, but is what we call local data collection. Local data collection basically means we collect the data where the data is generated. Meaning if you have 50 servers running somewhere, either in the cloud or on-premise, we tap directly into where those log files on those servers are generated and send them to Sumo from each of those servers individually. That's what we call local data collection. The opposite of that, sort of a completely different paradigm, is sort of centralizing all this, right? As you can see here, you again have these 50 servers, but they're not talking to us directly, but they are sending this data to a piece of infrastructure, a server, or multiple, depending on volume and other things, that is also managed by you guys. And then this, all these log messages and all this data is centralized here and then forwarded to Sumo Logic from there. And then, as you can see, last but not least, obviously a lot of the data that people ingest nowadays is actually cloud generated, or is data that lives in the cloud to begin with. And there are a variety of integration points that we'll talk about today that Sumo allows you to use. But for all your regular logs, when you think about regular logs, operating system logs, application logs, things of that nature, most customers apply one of these two paradigms primarily to get the data ingested. Like Mario said, this is not a black and white discussion. Most people employ a hybrid approach to make sure that they have the best possible approach for each individual data set that they have. But generally speaking, we have to decide: do we want to centralize log collection, or do we want to do it locally? And we'll speak about the pros and cons for each of them, as well as where they apply most typically here in the next couple of slides, so you guys get an idea. If you map that to your environment and what you guys have, what may be the best approach for your environment. Okay, so local data collection. This paradigm, or this approach, basically, is basically that you install our collector, which is just a small piece of software that we provide you. I'll show you in a little bit where to get that from. You install that on all the target hosts, and target hosts are machines that have logs that you care about having in Sumo, right? So you install this little piece of software on your target hosts, and then you configure it to send certain log data from those target hosts directly to our backend. This ultimately happens via an HTTPS connection, so it's basically encrypted, an encrypted SSL connection. Typically, this is meant for the following source types: operating system logs, both for Unix as well as for Linux, right? In the Windows world, these are Windows events that come from the WMI API. We have a source type for that. In the Unix world, these are files, var log auth, var log messages, depending on the flavor of Unix that you guys are running. Also, other local file types that are typical in this, anything middleware, right? Tomcat, Apache, whatever infrastructure you're running there from a software perspective, as well as all your custom application logs, if that's something that you want to send to Sumo. Also typical for a local data collection paradigm is if you're using Docker and you want to get your container logs and stats into Sumo, there's a source type for that, for this paradigm. If you have devices like network devices that do not, obviously that's an appliance, you can't install just a piece of software on there that we provide. A lot of times, what people will do is have dedicated machines running our collector on it that will listen for syslog, which is how you would then forward your firewalls or routers or other network appliances logs to there, and then that will be forwarded to Sumo. And that's sort of what I meant with hybrid, that not one, it's not a black and white approach. Even if you decided that you want to do local collection for the most part, if you have an on-premise environment and you have network appliances, you're going to need some sort of centralized syslog facility in order to ingest those logs, because there's just no way of getting to those otherwise, right? That's just a limitation of it's an appliance. It doesn't allow us to install a Java program on it, right? So most people will need at least some of that, even if they decide to go with the local data collection in general. And then, obviously, local collectors can also execute scripts. Hit up cloud APIs, pull data from there, pull data from databases or convert binary data to text in order to ingest it. So this is sort of the catch-all for for all the things that are not supported natively. So what are the benefits and the drawbacks of this approach? Local data collection, again, installing the collector on all your target hosts, has the following benefits. There's others, but these are the main ones. You don't have any hardware requirements. You're pretty much up and running really quickly because you use the hardware that you already have. Again, 50 production web servers, you just install the collector. You don't need anything else in order to get these logs into Sumo. Obviously, there is a large, we support automating this process if you're doing this at scale. Installing a collector manually once or twice is not a big deal. Doing it 30 times, nobody wants to do that. We have a variety of options that allow you to automate this, most notably via Chef or Puppet or Salt. But there's also people that have custom scripted this entire process. So from that perspective, we can automate the whole deployment and process if we want to. The downsides or drawbacks of this approach that most notably are present is that the computers or the target hosts need outbound access to the internet. Again, that outbound access is obviously HTTPS, so port 443, but it's basically the entire AWS IP range. So every target host needs outbound access to talk to us directly. And then, of course, the collectors themselves, they're doing work. They do use some resources on your target hosts. That resource usage is typically not a big deal because one individual host doesn't produce that many logs, and assuming your production servers are not completely maxed out in terms of their resources, but this is something to keep an eye on. Of course, if you have a server that's constantly at 95%, adding another process may not be the best idea. So those are the two main drawbacks. The outbound internet access issue, it obviously depends a lot on your business and the infrastructure that you're monitoring. We see this predominantly as an issue for Windows domains, large domain controllers, and things of that nature. Most customers nowadays, at least part of the environment, is web-facing anyway for the business that they're running. So in that case, that becomes less and less an issue because everything's connected to begin with. But that's just something I want to point out. If you are seriously worried about having outbound internet access on any target hosts, then local data collection may not be the best approach for that box or that set of boxes. Typical scenarios where we see local data collection is customers with very large amounts of servers. At some point, centralizing it, as we'll see in the next slide, at some point it becomes a scale issue. If you have large amounts of servers, chances are they're like grouped into groups of doing the exact same thing. Our orchestration automation and automation means allow you to manage this fairly effectively. So typically we see this for very large customers or large amounts of servers, both for on-prem data centers as well as infrastructure that's running in the cloud for either one of them. So that's on the local data collection side. Let's talk about the centralized piece a little bit. So the centralized is sort of the opposite of that, right? The Sumo Logic Collector is installed on a set of dedicated machines, so you no longer install it on the target hosts, but we have dedicated hardware, and we would recommend dedicated hardware because at that point volume increases, and we don't want this machine doing anything else. And then our target hosts will get their data to this centralized infrastructure via a variety of different mechanisms that we'll talk about in a second. And then that centralized machine or decentralized machines will then forward this data to the Sumo Logic backend. And there is a variety of ways how we can accomplish this. So this is not one, again, very, very different options in order to get this done. So our collector can act as a syslog server, right? And then your infrastructure, your operating system, and your applications just syslog data to that collector or to those collectors that we have dedicated for this purpose. The collector will then take that data and forward it. This is similar to what we saw for the network appliances, only in this case you're doing it for logs that you could collect otherwise, right? Typically, if that's the case, on the target host, you would be using syslog ng or our syslog. We're seeing lately a lot of fluentd coming in there because it's a lot more powerful than the other syslog tools. But that would basically be you take all the logs that you care about and you forward them to the centralized location, which then takes it and sends it to us. That's not the only option. What we also see people do is have actual syslog servers running on a set of infrastructure, their applications and other machines sending their logs to those syslog servers, which then apply rules to them, write them to files, and we then just pick up those files, right? So anything that you can do with either existing or planned syslog infrastructure, we can tap into at any point in that process and collect the data and send it to us. Obviously, we can also collect Windows events remotely if you don't want to do that locally. This goes back to what I just said with the outbound connectivity need. If we don't want that, we can have a centralized machine that collects Windows logs from the target hosts. Again, this happens via the Windows WMI API. But the target hosts at that point no longer need outbound access, only the centralized machine will. And then, of course, the same thing as before, any collector can execute any script, hitting up cloud APIs or talking to databases or so forth. So what are the drawbacks and benefits here? We don't need outbound internet access. So the target machine does not need outbound internet access because, the dedicated collector acts sort of as a proxy, if you will, to the internet. If we have existing logging infrastructure, if you already have large amounts of syslog stuff somewhere, if you're already archiving your logs in a centralized location, if via any means, Logstash, syslog, whatever it may be, then we can leverage that. And as I already said, we can tap in at any point in that process that you may already have and just pick stuff up. That way you don't have to reinvent the wheel just to use Sumo, right? The biggest disadvantage or drawback for this approach is scale. If you have thousands and thousands and thousands of machines, you will at some point need a lot of dedicated machines to do this because there's a volume limitation, right? You're also sending it over the network twice potentially on your side, because first you send it to the dedicated machine. Depending on how that sits, you have to send it out. So it's a scale limitation. If you have a very large amount of target hosts, I wouldn't recommend this option. You need dedicated hardware for it. The more target hosts you have, the more dedicated hardware you need, which you then have to manage and monitor, which is the exact thing you want Sumo to do. And then there is some configuration complexity in terms of failover or in terms of load balancing that you may have to take into account when you're doing centralized data collection, especially as it's at a larger scale. If you can do with one collector, it's not that big a deal, but you still have to worry about failover and potentially load balancing it. So it adds in general more complexity and infrastructure to your whole operation of getting the logs out of there. That's those are the main drawbacks. We see this mostly for customers, as I already mentioned, that do not want the target host to have outside or outbound access, or for customers that have existing logging infrastructure, if they have, syslog infrastructure, Logstash already running, then we typically tap into that for, take advantage of the work that was already done. This is mostly an approach for your on-premise stuff. It's very rare to see centralized paradigms in cloud environments, just because the nature of cloud environments, the ephemeral nature, the elastic nature, the automation options there typically make it less attractive to build an entirely different set of pieces just for the logging, if you can basically build it in for free once and never have to think about it again. So that's on here.
Hey,
And then
Olaf,
last but not,
Olaf,
yes.
it's Mario. I want to read out a question. It's actually a bit of a question and a statement from Jonas. He's saying, question, I installed a Sumo collector on our Windows server. We didn't open any ports, but Sumo was able to collect data. This server is on AWS.
Yeah, so what that means is that the collector has the ability to outbound, to send data outbound on port 443. That's the only requirement that our collector has. It doesn't require any inbound connectivity. So, but it requires outbound connectivity. And we see plenty of customers, not in AWS, but people with large Windows domains, for example, where we're collecting the domain controllers that don't want the controller to have any outbound access at all. Everything that the domain controller would need in terms of from the internet, like updates or whatever, all that, it's funneled through other central locations. So if your collector is installed on a machine, AWS or not is irrelevant here, and it can send events to Sumo, then all that means is that port 443 outbound is open for that machine.
Yeah, thanks, Olaf. Actually, Jonas just responded that outbound ports are set to 0.0.0.0, right? Which makes sense.
Well, then, yes, and that means everything to the outside.
Mm-hmm.
Yeah.
Great.
Right.
Thanks.
That's very normal, right? Typically, people are more concerned with inbound ports, not with outbound ports. But again, we have several thousand customers. Not all of them would agree with that statement. A lot of people are also concerned with outbound. But that's why the outbound requirement is port 443. And to elaborate, because it came up, some people will then ask, well, can I outbound on port 443 for certain IP addresses, right? Can I just poke a small hole in my firewall? The problem with that is, from our perspective, and this now it gets very AWS-like here, but we live in AWS, and one of the advantages of our service is the elasticity, right? We provision machines as we need them. If demand goes up, our provisioning of machines goes up, right? AWS, unfortunately, is currently not able to provide us with a stable set of IP addresses that they assign to us as a customer, which means we cannot tell you, in turn, what those IP addresses would be for your firewall. So the hole that you would have to poke in your firewall if you were to do so is pretty large, because it covers the entire AWS IP address space, which, as you can imagine, is pretty large. That said, that's an issue AWS is well aware of. There's a lot of people that have a lot of trouble with that, and that's something that will at some point be addressed, but it's not currently addressed yet.
Excellent. Thanks, Olaf. And thanks, Jonas, for the question.
Yes, so if that didn't answer your question, then please ping Mario. Unfortunately, I can't see the questions in my GoToMeeting here, so Mario's going to have to play. Have to bug me in your guys' case, because I can't see them for whatever reason. All right. So third, and this is not a different paradigm, this is just a different means of collecting data, right? Everybody's moving at least part of their workload to the cloud. We have customers that are cloud only, very few customers that are on-prem only. There's at least some pieces that everybody's almost moving to the cloud. And obviously that's an entirely different beast in terms of getting this data from wherever that cloud may be to Sumo. So the source types that you will see on on cloud environments are dramatically different, right? We saw back here, oops, the source types for local data collection, are local files, anything that's written to a log file, or Windows events, or whatever Docker produces, right? So these are your typical source types that you would have for log messages. In the cloud, obviously, we can't read local files on your Linux server from the cloud. That's obviously not gonna happen. There's no access there. So the source types vary quite a bit. The main source type for for cloud environments, and this is specific to people using AWS, which is basically 99.9 of our customers that are using the cloud are using AWS in some capacity, sometimes in addition with other cloud providers, sometimes just AWS. But anything that is written to S3 buckets, we can collect natively. We have a native integration with many AWS services, S3 being one of them. So basically, you can write data to an S3 bucket, and we can pick it up from there and ingest it into Sumo. This most likely, or in vast majority of cases, are AWS audit logs, things like CloudTrail or ELB logs or your S3 access logs, because AWS by default will write those to S3 buckets, right? But you could also write other things to S3 buckets like your application logs, and and we can pick them up from there. So it doesn't necessarily have to be audit logs. So that's one source type. Another one is this concept of an HTTPS endpoint. This is just an API. It's a URL that we provide for you that you can create for yourself, and you can then post data to this URL. Most notably, people use this, especially this is picking up quite a bit. If you have Lambda functions, you can log from those Lambda functions straight to our API endpoints, and we can then ingest this data. Or if you're using Akamai as a CDN, Akamai allows you to log straight to HTTPS endpoints, so you can ingest your Akamai's logs there. And last but not least, we have custom libraries for different logging tools, Log4j, log for the one for .NET. If you use those libraries, you can log straight from your applications to our endpoints without having to go the file route or anything like that. And last but not least, we do integrate with other tools. The list of tools that we support there is ever growing. Right now, most notably, obviously, we can collect Google events from the Google API. If you are using, Google for Drive or authentication or whatever it may be, and then the same thing is true for O365. If you're using that, we can collect the logs for your O365 usage straight cloud to cloud without you having to do anything. Everything else, from an integration perspective, we currently have to script. But that list of integrations is growing. We're also seeing now third-party vendors actually integrating with us the other way around. OneLogin, for example, has just recently has functionality to send OneLogin events straight to Sumo from their console. So in that case, we don't have to build integration anymore because they already did. Benefits, you don't need to install anything. This is completely agentless. So in that regard, there's nothing to manage. It's a beautiful thing. S3 specifically has latency issues. That's not on us. That's on S3 itself. And there's no guarantee of when that data is written to S3. It's a best effort type deal that AWS gives us there. So there's some latency issues that are potentially occurring. And then for the HTTPS and post, there's no built-in caching, right? If for some reason the API on our end is not responding to data that is being posted, and you want to make sure that data doesn't go lost, you would have to cache it yourself. For example, alternatively, if you're collecting data locally and a collector that is reading a file is losing connectivity to our backend, the collector will cache the data, and as soon as it restores connectivity, it will backfill it. So the risk of losing data is not present. If you're using HTTPS endpoints, you have to worry about the caching yourself, which most people do. It's not a big deal, but you gotta handle it in your scripts, in your Lambda, in your libraries, whatever. It may be that it's doing the posts, right? So that's that. Typical scenarios, of course, AWS customers / AWS only customers. It is very rare that people rely completely on these cloud data collection options. I mean, it's happened. We have people that do this, but in the majority of cases, you may, even if you're operating in AWS exclusively and you have EC2 instances running your applications, you may choose to collect the logs from the EC2 instances locally and collect the AWS audit logs via S3 integration, right? So you have a mix, but it's very rare that people are completely agentless. It's definitely possible, and it's a nice thing when you can make it work, but it requires some upfront work to get every single log ingested like that. So, sorry, I have to take a drink here. So that's sort of on the paradigm side. That's what I wanted to cover. When people start the Sumo logic path, a lot of it's very easy to install a collector and get data flowing, right? Easiest thing in the world, takes 2 minutes, which is beautiful. But when you start thinking about the bigger picture and the scale of your environment, we just want to make sure that that that's not the only option. There is, depending, on a high level, do I do local, do I do centralized? And then with each of those, there's a couple of different ways to go to collect the data. This session just wants to ensure that you guys are aware of that, and that when you get past the point of like testing Sumo, and you want to fully implement it, is that you make the best decisions for your organization and your infrastructure. So before we move on to the next topic, are there any questions? You can use the questions tab, or Mario, we can unmute for a minute about this before I move on.
Sure, let me try the unmuting. Unfortunately, there is no easy feature, and I have to unmute everybody one by one. But if anybody has a question, I can unmute them in particular. Any questions from the audience? No, I guess we can move on, Olaf.
Okay. So the next topic I wanted to talk about is just quickly look at how to install a collector. And I am not installing one. I'm just going to show you the UI and the steps to do so for those of you who haven't done it yet. So this is a training instance that we have. And if you have the permissions to actually install a collector, then you, under the Manage menu, will see a collection item. If you don't have permissions to installing collectors, you won't see this. But if you click on here, for one, you can see a list of existing collectors. In our case, we just have a few, right? Over here, you can see what type they are, hosted versus installed, right? So this is basically cloud integration stuff, and these are installed collectors. And that's basically what we see. This is obviously all dummy data that you're seeing here that we're using for demo purposes. But if you just wanted to install a single collector, you could download it from here by clicking on the Add Collector. Then you say Installed Collector. And then all you do is basically pick, the binary that mostly applies to you. As you can see, we support pretty much anything that's common these days from an operating system perspective. We have made this run on all kinds of Unixes too, if that's an issue. So you would just download the binary and install, according to however you install other tools on the operating system in question. So that's that's item number one. Once you have a collector installed, and I'm just going to show you this on here, the collector by itself is, if you don't do anything, by default doesn't do anything. It's just a process that is running, but it's not reading any logs. If you want to add a source to a collector, and a collector can have multiple sources, right? But if you just wanted to add one, you can click on Add Source for that collector. And then again here you can see the source types that I alluded to earlier. We can read a local file, meaning the file is being generated on the box where the collector is installed, var log messages, for example, right? Or any application log that you guys may be writing. We can read files remotely. This is not very common, but this would happen via SFTP or SSH port 22. So you could read files on a machine remotely if you chose to do so. Like I said, we can listen syslog, act as a syslog server, and then whatever data you're sending to that IP port and protocol, you can see here that's the only configurations we have. You can pick between TCP and UDP and then some port, default being 1514, and whatever you broadcast there, the collector will pick up and ingest. And that was one back too much. We can ingest Docker logs and stats, should we be using Docker and be interested in those. That's the container logs and the container stats. That's not the logs of whatever is running in your container, right? We can execute scripts and ingest whatever those scripts output, right? So again, this is the catch-all if you're trying to ingest something from a database or something like that. We can get that from here. We can ingest Windows logs, both remotely and locally, as well as Windows performance stats remotely and locally. The two items you see over here are not log source types, they are metrics source types. So I don't know, maybe you guys know that we not only ingest logs and let you search them, we, since roughly a year ago, a little less, we added functionality to ingest your traditional time series metrics. So these two sources for the installed collector are meant to accommodate for that. This is basically just a graphite source. Looks very similar to syslog because that's what it ultimately is. Any graphite formatted data that you're sending to this source, we will ingest. Things like collectd, statsd, or any custom libraries that you may have in your application that may be producing metrics. You know, we can ingest that through this source type. And then we built, to help people out, we built this host metrics source type. And this is basically meant for people that use the local collection approach, that have this collector installed on all the boxes that they're looking to monitor. And in this case, we can select a set of, you know, your typical basic infrastructure metrics that we can select and ingest from those machines, and then use in our metrics functionality. So these are not logs; these are numerical time series data points. But you can collect it natively from the collector. You don't need collectd or statsd or anything other than that necessarily to get these collected. You can use the collector itself. Obviously, you pick how often do you want to collect and which are the ones that you care about, and then we will ingest those metrics. So that's on the yes.
Olaf, let me interrupt you. It looks so easy to collect those metrics as well. And slightly, have a couple of questions here, not on metrics themselves, but on collectors. So the first question is from Andrew, and he's saying, is there an automated way to push out the collector to multiple machines in AWS? Can it also be installed via user data when instances are deployed with a config for both Windows and Linux systems?
So yes, the answer is yes, and there's multiple ways. Depending on how you are using AWS and how you are orchestrating your software there. Obviously, you can bake the collector into your AMI, right? That's the most basic way. If you are using AMIs for different server types and you're launching them and getting rid of them and launching them, the collector can be baked into the AMI, and whenever the AMI is launched, then the collector process will be started. Obviously, at that point, the collector is pre-configured to do certain things, right? So that's the most basic option. If you don't want to bake it into the AMI, or you don't bake anything into it, or you have a very basic AMI and then use other tools, you can obviously use Chef or Puppet, or whatever, or there's a million other tools that would do the same thing to push out the collector, push out configuration for the collector, and then push out, and then start the collector process. So can I ask a question back? What is the AMI an approach that would be interesting there, or is it more some orchestration tool? And I'm sorry, you have to type this back.
That's okay. Let me see if I can unmute Andrew here for a second. Andrew, can you hear me? So Andrew, you've been unmuted if you actually want to respond to Olaf's question. Oh, he doesn't have a mic on this. So that's okay. So Andrew, the question was, I'm sorry, Olaf, can you repeat the question to Andrew?
Well, the question is, so as I said, obviously you can bake the collector into the MI. That's the most basic route a lot of people go.
All right. Actually, sorry, yeah? He's responding. He's saying that they're trying to stay away from managing AMIs.
Okay. Well, then the second question is, how are you managing the instances that you're launching? What tool are you using to do so? But we can look into this in a little bit more detail. It wasn't part of my plan, but maybe it should be. The options of using orchestration tools for this purpose, and what our collector does for you in that regard.
Yes, I understand that they're heading towards using a tool like Ansible.
Ansible, okay. Ansible, yeah. So, in short, and our documentation has a lot of examples about this. In short, yes, we can use Ansible or any tool of your preference to push the collector, configure the collector, and start the collector. And we have options. We have options for this. If you go to help.sumologic.com, we should be able to find. So I want to go to here under the send data menu. Let me see where that's at. Use JSON to configure sources. So in essence, like what I just showed you, right? If you install a collector and then you go to add, oops, that was the wrong one, and then you go to add source, and then you add the source manually. Of course, in your case, if you're launching EC2 instances and using Ansible to configure them, then that's not what you want to do, right? But as I said, the collector, and you can see this if you're looking at the advanced tab for each of these. Down here, you can see is a section called collector management. And there's basically two modes that this collector can operate under. The default one is cloud-based, and that essentially says I can manage this collector via the UI, like we just did, or via we have a REST API that you can use. A second mode, and that's not the default, so you would have to specify that, is by using the local configuration file mode. And that means that the collector gets deployed with a set of local config files that basically tell it what the sources are. And as soon as a collector comes up, it will use those local config files, and it will listen for modifications to them, which in a ephemeral environment isn't that big a deal because stuff doesn't live long enough. But it doesn't have to be cloud managed. You can automate all of this with Ansible. And this link here, use JSON to configure sources, will show you how to do that.
Thanks, Olaf. There's a second question from Patel, and it's how do I create a Lambda collector for? I'm sorry. How do I create a collector for Lambda/CloudWatch logs in AWS? What permissions are needed? I'm assuming you can point them to.
So I can't speak to the AWS specific part. Typically, if you do Lambda CloudWatch, what you will do is, and this was the second thing I was going to show you anyway, if you go to the hosted collectors and their source types, you will see these source types. Down here, we're seeing, with the exception of the CloudWatch metrics and metadata, these are all S3 based, right? So we have different source types for CloudTrail and ELB and S3 because the way we scan the path is slightly different, but these are all, at the end of the day, you tell us where your bucket is, you tell us where in that bucket the files are, you give us an access key and ID that has permissions to read that bucket, and then we will go and grab the data out of that bucket based on some interval that you have here. Lambda, which we're seeing more and more, typically you have Lambda scripts that pull from CloudWatch, and then they just post to an HTTPS endpoint. And what this will give you at the end of the day is this. It's just a URL. It's specific to you. It's just an API, and your Lambda function will go ahead and post data to this URL. Now, I don't know on the top of my head what the AWS configuration for this is. I can tell you, however, if you go to our GitHub page, there is Sumo Logic GitHub. There is a Lambda function for CloudWatch there. Yes, so and I don't know why there are conflicts in this file, but I can find the. Oh, here it is. So this is basically a Lambda function that you can use that will allow you to do so. Many people take this and rewrite it to do other things. This is just a baseline. But how that exactly works in AWS, I would have to figure out. I don't know on the top of my head.
And I also just posted a link on the chat and on the questions to everybody, just kind of showing you what you do, in case that's your question, Patel, what you do on the AWS site to grant access for us to go and read your CloudWatch metrics from you. So I just sent you that.
Well, his question may not be about metrics. You can ingest logs via CloudWatch with Lambda. That's probably what is. But you're right. The policies that are outlined for the metrics may be very similar to the ones for the logs. Yes, but I don't know the detailed policy for that. That's something I'll have to look up.
Okay. Yeah. His follow-up question. Sure. His follow-up question was, what permissions do we need to IAM access secret keys? So this post that I just sent you, this link actually shows you a JSON policy that you can build there.
Yeah, so here, this is from our docs. This is the function. Oh, so maybe it's actually in here. This is the function. This is the same thing that we just looked at.
Yeah.
And then down here, it may actually tell us what it actually doesn't tell us what the policy is. But yeah, that's something I'd have to look up. I don't know that in detail on top of my head.
Okay. Thanks, Ola.
But the basic process is lined out here. I'm assuming somewhere in here, and typically we're pretty good about documenting AWS policies for integration points. I'm not sure why it's not in here. All right, I hope that answered your question.
Yep, I'll continue to look for that policy while you move on.
Okay, so last but not least, what I wanted to just show you, we talked about the two metric source types here, graphite and host metrics. We also support a metric type for the cloud-to-cloud piece or for the hosted piece, which is CloudWatch. Not logs, but metrics. As you know, that's how you can get your AWS metrics. In this case, you just select the region you're operating under or you want to collect, as well as the namespace. That's what they call it. This is typically a one-to-one correlation with just basically AWS service. So you could pick ELB or DynamoDB, and then whatever metrics that API provides, you can send to us. Works very similarly to the S3 integration. You just need to create a user and a policy that has access to read these, and then we will, at whatever scan interval, hit that API and pull down those metrics. This AWS will charge you for. So every API call that anybody makes to the AWS metrics API, there is a cost associated with it. It's like a couple of cents a call. Just keep that in mind if you're doing this. that this it's not our cost, it's an AWS one. All right, so that's sort of my short run through the the collectors and the different options there. Again, to reiterate, the main thing here is not to install a collector. That's in itself is pretty simple, but to sort of figure out in my environment, how do I want to deploy these collectors in the long run, right? What am I comfortable with? Is outbound access an issue? Is automation an issue? What are the different things I have at my disposal to find the best deployment strategy for all my logs, right? Because now we're not talking about doing this on one or two boxes, but to do it on all of them. And if there's a lot of them, then those things become important, right? Because ultimately we want you to use Sumo, not having to configure it. And so these things, it makes sense to think about this up front before you get too far into one way, and then it's a lot more effort to revert. So, and since you guys are just starting out with the tool and probably haven't spread out or scaled out entirely, it's a good time to think about this for a minute. If you ask me, the majority of people employ the local approach just because it's the simplest, and especially in the cloud, the most streamlined and most native one. But there are certainly other options if you don't want to do that for one reason or another. So,
Olaf, I'm going to pause you here for a second. Another question from Vin. Can you please elaborate on CloudWatch logs? I'm sorry, can you please elaborate on CloudWatch metrics versus CloudWatch logs?
Okay, so the nomenclature here, oops, that was the wrong one, is a little bit messed up. So CloudWatch as a service that AWS provides, right, can output two different things. It can output logs if you decide to log to CloudWatch from your from the AWS. You can configure different services, like let's take ELB, to log to CloudWatch, and that's sort of their interface to the outside, right, or even to their own console if you look at logs there, right. Logs are just logs, your typical logs. This could be, your ELB logs, your S3 access logs, your CloudTrail logs. This could be logs from applications running on EC2 instances, but they're logs, they're text files, just regular logs, and that can go through CloudWatch to come to us. In most cases, it actually doesn't. If you want to get the logs into Sumo, there's better ways than funneling them through CloudWatch, mainly either Lambda or us integrating with S3, right? By default, most AWS audit logs go to S3. That's where we should go pick them up. It makes no sense to funnel them through something else. The metrics are an entirely different set of values. Metrics are, as I said before, are traditional numerical and time series data. So there is a, let me just show you this. If I find it, metrics, here is a, and I can put this in the chat. This is a website that from the AWS docs that will show you for each of the namespaces what the metrics are. And as you can see here, this is the list of namespaces that you would see on our website. And if you here go to load to ELB, they always break this down into two different sections. One is the metrics. So, if you pull metrics every minute, you get an active connection count. You get a healthy host count. You get how many ELB 4xx codes did I have? How many 5xx? Same thing for the target. You get a new connection count. Or you get a request count, right? So these are just numerical values that you get at whatever interval you're scanning, and you're getting them for each one of these dimensions. So you get the new the request count by availability zone. One level lower, you get the request count by load balancer. And then I believe this target group, I'm not entirely sure what this is. It's just a different slice and dice of this value. So you always get numerical values for these metrics listed here for each of these dimensions listed down here. So the difference is one is a log, it's actually text, just either traditional log or AWS audit log. The other one is a metric, a time series numerical value. We collect them differently, we store them differently because they're completely different things, right? But we allow you to search them together and to have a single pane of glass for both of them, right? I don't know if that answers the question, but to collect logs through CloudWatch is no longer that typical. That used to be. It's more typical to get metrics through CloudWatch. Logs, there's other ways of getting them. So I hope that answers the question about what the difference is. That logs is truly just text data, log data. Metrics are a completely different data set.
Yep, Vin is saying thank you.
And this URL is really good if you are interested in AWS metrics. This is the place to come. It describes all of them. As you can see, there's actually not that many. Like in total, there's a couple of hundred. So it's not like a graphite server that outputs 10,000s of metrics. So it's pretty easy to wrap your head around. All right. So that was it on the collection side. Any other questions?
No questions at the moment. Thanks.
All right. So let's go to the next topic. So let's assume you figured out what your collection paradigm is, so you at least are thinking about it. Let's talk about metadata. Mario already alluded to this. This is actually the main topic of this session. To me, the main thing we want to get right. If we get this right, a lot of other things don't matter so much. If we get it wrong, same thing. You can do a lot of other things right, and it doesn't help too much. So let's talk about metadata. What is metadata? Metadata is basically just different tags or fields that we store with each message that we collect. Most of these values are basically defined by how your sources are configured. For example, I know the name of the collector that a message came from. And this is for every individual message we ingest. We store these metadata tags. I know the name of the collector it came from. To go back here, that would be, in this case, the name of the collector. Let me expand on. These are collector names: Artifactory, Loggen Data. So these are weird names because this is a dummy environment, right? These are EC2 instance names. But these are the collector names. We also always know the name of the source. If you expand on this, you can see this guy has 5 sources. Artifactory access is the name of one of them. That's the name of the source. So I know the name of the source where this data came from for each individual message I'm ingesting. We know the name of, we call this value source host. That's a freely configurable field for each source configuration. Typically, we leave it empty and let it default to the host name. Same thing for the collector. It makes no sense to give something a name that host names is what your users are going to know. So if we leave it empty, it defaults to the host name. That's what we typically would do because that's what your users are going to know. We always know that if it's a file-based log, we always know the path and the name of the file that a message originated. And this is the full path. So if it came from varlog messages or varlog application, some log file name, we always know exactly where that message originated if it's a file-based source type. And then last but not least, we have this value source category. This is the main metadata tag. This is the tag that we want to use and think about the most. These other ones are sort of implicit by their configuration. This one is the one that we can do whatever we want with, and we want to think about what we want to do with it to make sure we do it. We do what's best for our environment and use cases that we're trying to address with the Sumo logic usage, right? So these other ones are secondary. The main metadata tag is source category, and as you can see in here, I'm just going to add a new source, and this is true for both hosted and non-hosted. I'm going to add a file source. Source category is a value that I can specify. I can leave it empty. I can put something in here, whatever I want. You can also hear source host. Again, leave it empty, defaults to the host name. If you do that, which is the most meaningful to your users, most likely. But here is where the meat is. This is the tag that we will use to find the data later, to index the data later, to provide access control on the data. So it's the main metadata tag that we wanna design around, and I'll show you in the next couple of slides what our best practice here is. So, source category, main tag. So our recommended nomenclature for the source category value is a component-based or hierarchy-based nomenclature, as you can see here: component 1, component 2, component 3. Typically, this would go, or that's what we recommend, is this goes from least descriptive to most descriptive. Or if you go the other way around, from detail, and then the higher up you go in the hierarchy or the string, the more higher level grouping you are achieving, right? So, for example, and there's going to be a lot more of this, so just bear with me here. I could say I want my source category to be defined with the following pieces. I want my environment to be in there. I want my application name to be in there because I'm running multiple applications. I want the actual application. What is this could be the part of my stack, right? What is it? Middleware? Is it database? Is it what is it? Is it operating system? And then I want the actual log type. So these are the 4 components that I've chosen here. And you can see how this would look in practical life, right? The highest level component is the environment, so prod versus dev. Or if you have other environments, obviously there would be another few, right? The second one I said is the app name. So this is my app 1, and of course I don't have an app that I can put here, but you guys probably do. So you can see here my app 1, my app 2. These are just 2 very distinct applications, probably being owned by different teams in your company. Completely different sets of data, maybe not, and that's sort of the conversations that you guys need to have when you're building this nomenclature. But in this case, let's just say they're 2 completely different apps owned by different teams, very little overlap. So we use that as a second component, right? And then within that, we're basically saying, so this is Apache access. There's also Apache error, and these are collected locally from my EC2 instances where my web server is running. But I also have CloudTrail logs, that pertain to this app. So I'm going to also put them in here. And then the same thing we have for our dev environment. It's basically a mirrored setup with the only change here being dev. Then I may have another application. Again, I'm doing prod my app 2. I have different types. This is a different application. It's running different. It's running on different parts of the stack or different software, right? In this case, I have Nginx logs. I have Tomcat access logs. I have Catalina out logs, and I'm using a database. I also have MySQL slow query logs in here, right? And then I have the same thing for dev. So that's sort of the thought process here. I want to be able to find high-level groupings of my logs that make sense to my specific Sumo use. And with that, the most important metric is which of these, how is this data predominantly going to be searched? And I say predominantly, not because any of this scheme prevents you from doing anything. You can do you can search for any combination of data regardless of what kind of scheme you choose here. So there's nothing that you cannot, or you're not going to limit yourself. But optimization, I'm trying to optimize the 95%. If there's edge cases and stuff that people don't do a lot, that is not
muted.
I can live with that. But I want to make sure that the things that a lot of you do many times, that those things are optimized. And that's sort of the goal here. It's not, it's not black and white. There's got to be certain things that are just, they're edge cases. They fall out of the 95%, so we can live with that. But the first or second group here, or component, we want to make sure that they group your data in a logical fashion in terms of how you're searching it. So this scheme here, right, will basically is optimizing for teams that are, like for one, are distinct in terms of the my app 1 and my app 2, right? You This is not optimized for searching this data together a whole lot, right? In this case, for this example, I don't need to, right? So I'm either searching data for my app 1 or searching data for my app 2. Very rarely or not at all am I searching across both. And it's highly segregated in terms of prod versus dev. That's one of a very common one, but it doesn't necessarily have to be. So bear with me. I have some more slides, and I'm going to show you first the reasons we're doing this, and then some more examples, and hopefully that makes more sense. First note, not all of this does have to have the same amount of levels, right? As you can see here, this one has 5, this one has 4. Some customers use 2 or 3, other customers are going to use 7 or 8, depending on how much level of detail they want to add to the end of this, right? The most important ones are the first and the second ones. How much granularity you add after that is sort of up to you. Some people like a lot, some people don't. But the first 1 or 2 are the most important ones. And again, we want to group this data either with the first component or a combination of the first and the second, that logically groups this data into logical groups, primarily based off of that's a group of data that is sort of searched in isolation for the most part, right? Not in combination with other data sets. In our help, and I'm sure Mario can provide these slides, there's a little bit more color to this, but let's elaborate real quick the reasons why we want to do this. Reason number 1, simple search scoping. I want to be able to find the subset of data that I care about for any specific use case I may have with a specific search term and not having to have 4 or 5 search terms. So for example, with the scheme or with the nomenclature that we just looked at, if I wanted to search for all Apache logs for prod, I could run a search across for this, and I'm forgetting that for this first. So this is a valid search string that would find all Apache logs for prod in my environment, right? I'm wildcarding it at the end here, which will find the Apache access logs and the Apache error logs. Or I could say, I want to find all Apache logs for all environments, right? I don't care only for prod. I also want to look at dev and UAT. I can wildcard the environment, and I can wildcard here at the end again, right? So with very simple terms, I should be able to find the subset of data that I care about without having to do a bunch of Boolean ORing here to find different data sets. The reason that's important is, for one, it drives adoption with your users, right? It's easy to find the data. You don't have to remember 17 different things in order to find it. And if this matches, we'll talk about indexing here in a minute. If this matches your indexing scheme, people will get the best possible performance out of this. So simple search scoping is one reason we want to do this. The second reason we want to do this is because it allows us to index this data. And when I said earlier that the first or the first and second component are the most important ones, that's because of this indexing. These are probably going to be the groups that we index this data by. Indexing, for those of you who don't know this, at the end of the day, we index text inside Sumo, right? We take text and we index it. Now, obviously, a lot of the peripheral features that we built are sort of based on log data, unstructured data, structured data, semi-structured data, whatever you want to call it. But you can send us a book in a text file and we will index it, right? So if you don't create any indexes at all, everything gets indexed into the same index, which is obviously a very large index. And every time you search something, even if it's just a small portion of that index, we need to look through the entire index to find that small portion. In Sumo, we can build indexes to basically group our data into smaller indexes. In this case, and we use the source category value to drive that for the most part, right? There's some exceptions to that, but most 99% customers will use the source category to do that. And we use the first and second component to build these indexes. To go back to my use case here before, I said this is sort of optimized for I'm searching either within my app 1 or within my app 2. Right? That's the vast majority of my use cases. Very rarely do I search across them. In this case, I would create one index that contains all the my app 1 data and one index that contains all the my app 2 data. So the first and second component is what we're using to create these indexes. We'll talk about this in a little bit more detail here in a minute. And then last but not least, if we have access control requirements, we call this RBAC, row-based access control, meaning not all users are supposed to be able to see all data, right? I can use a search string that looks like this to whitelist a certain group of people to only be able to see my app 1 data. But because it's wildcarded here, they can see everything that falls under that, right? Again, you have a team that manages this one app and another team that manages the other app. They don't want each other to see their, the other guy's data. You could create roles and prevent them from seeing certain data sets. So those are the three reasons why we want to do this. It allows us to very simply find the data that we care about. And again, this is important. The same with the partitions. Performance is predominantly a function of how much data our engine has to go through, right? If you start with all the data every time, only to filter 95% of it out later, right? That will work, but it's going to be inefficient, right? It's going to be inefficient from a compute perspective, and then ultimately, it's going to be your time that's going to be wasted because you have to wait longer for a search to return than you have to. Search scoping, especially if it's simple, allows us to reduce that size off the bat, saying I only care about my app 1 Apache data, ignore all other data, right? So good search scoping is step number one to getting better performance. If that scope is then being able to actually hit one index or another, right? Then it gets even better, because then not only am I limiting the data that I'm bringing back off the bat, but I'm also only looking in this one spot. I'm not looking across all of it. So in this case here, if you had an index that was defined like this, and you wrote a search like this search would only look in this index. It wouldn't even look in here, because this is a true subset of this, right? And our engine is smart enough to rewrite these searches. Think like the Oracle Query Optimizer, right? Who rewrites the queries you wrote because it's telling you didn't do it very efficiently. This is the same. It's sort of the same thing. The users don't need to know about the indexes, right? Our queries use them automatically, and that's what we want to. That's what we want to drive. We want to make sure that we can get our use cases without bringing in all the data only to throw it out later, because that's going to cost time. With the smaller subset you start with, and that's what good search scope will do, and partitions will do, the faster your search is going to perform. So that's the two main reasons. Access control is just a benefit, right? We want to make sure that if you have access control needs, that you don't have to constantly edit the rules just because you added a data set, right? These higher level groups, again, allow you to sort of bucket the data in certain buckets, and then unless you add a new bucket, you don't have to deal much with it, right? So let's look at a couple of more examples, and then we can have some questions if you guys want. So what are common components that people are using? Environment, very common. Vast majority of people have that in there somewhere. It doesn't necessarily have to be the first component, but it's most often in there. If you're running different applications, the application name, whatever your name for it is typically in there, right? Geographic information. Which data center is it coming from? Which office location is it coming from? Or which AWS region is it coming from, right? That could be part of it. The business unit can be part of it. Is it network data? Is it operating system data? Is it security data? You know, whatever values, whatever groupings make sense for you is what needs to come in here. These are just suggestions and things that we see a lot. This doesn't have to be the way you do it in your environment. We just want to make sure that the first one or two components are good high-level groups of how you are searching this data, because that's, as we just saw, that basically drives how we index the data, and that drives how well searches are going to perform. So if you look at this example that we have down here, same components, but a different order, right? Again, none of this will prevent you from doing anything, but one is optimized for a different set of use cases than the other one. The first one here, where we have the environment first, is sort of optimized for I'm searching predominantly within environment, prod or dev. Very rarely do I need to look across both, right? The second one is basically saying I care about the environment, but not very much. It's the last component. It's just a level of detail, right? That's optimized for I predominantly search across all of it, right? And only sometimes do I care about prod or dev, right? So that's sort of, and this is a very simple example, of course, right? But that's sort of where we want to go with the source categories. We want to make sure we build these high-level groups, components in there that allow us to group the data logically as per our usage of the data. Just some numbers. If you have, and it depends on what the number of combination is, but if you have 3 or 4 component ones, and then 10 or 20 component twos, right? That combination gives you what, so I don't know, I don't want to do the math, but, if between component 1 and component 2 you have 20 or 30 or 40 distinct values, that's good, right? If between component 1 and component 2 you have 2 distinct values, that's not distinct enough. That doesn't help us with indexing. If you have 200 values, that's too many, right? In those cases, you would look if there's any other values that could be added that allow us to group this data, because we want to drive anywhere between 5 and let's say 50 distinct values between the first 2 components, right? From a combination perspective, because that's sort of a healthy number from an indexing perspective. Most likely, depending on how many components you decide to do total, it's going to be anywhere, between 5 and 20 or 25 distinct values in terms of combinations. That's sort of what we're seeing a lot. But if you have 200, you're probably too granular, too far up in the component. If you only have 3, you can do that, but then indexing at that level is not going to do much good, right? Because there's only very few distinct values there and distinct indexes that you can build. Sometimes that's how your data falls. Don't get me wrong. This, sometimes 90% of your data comes from one place, and then it is what it is. But if you're not in that scenario, then having anywhere between 5 and 25 distinct values in the first 2 is sort of where you want to fall. So before I move on, are there any questions?
Unmuted.
Does this make sense? I know this sometimes is a highly theoretical discussion without looking at actual searches. But for example, if I go here, right? Here I have. I'm just going to show you this. I have 2 Apache or 4 Artifactory source categories, right? So from a search scope perspective, I can say I want to find only the Artifactory access logs, or I can say, I want to find all of them, right? And now I'm getting all of them, and that's from a search scope perspective. If you're looking We'll look at the partitions that we built off of this here in a minute, but that's sort of the that's sort of the gist of what we're getting here. And what values you use is really entirely up to you, and what combination. That's not, these are things that we see a lot, but it doesn't have to be what you use. However you group this data, that's what you should use. All right, are there any questions about this?
No questions on the chat.
All right. If there are any, don't please ask them. This, as I said, this is the main reason we're having this session. To me, because that's going to drive a lot of things, down the road in terms of scale and performance. All right, then let's look at three more things, and then we can open it up for questions. The first one is partitions. I already alluded to this. This is one of the reasons we're doing this source category design the way we're doing it. And partitions are indexes for subsets of your data. They allow us to segregate your data into smaller logical chunks that are mostly searched in isolation of other partitions. Meaning, again, as I see here, this example, I'm grouping the MyApp data into one index and the MyApp2 data into another index because, rarely do I need stuff from both, right? Just one, some use cases look for MyApp1 data, some use cases look for MyApp2, all within prod. So I'm grouping them, indexing them together. And when I search them, I don't have to look through all my data. I'm only looking through a subset. Or as you can see here in this case, I created them for prod and for dev, right? Probably a little bit, probably not granular enough, but it's definitely a possibility. Like to do it like this. So what are we trying to accomplish, or what are the best practices when creating partitions? We want to have partitions that do not have overlap. With very few exceptions, I don't want to write the same data into two different partitions. Defeats the purpose. Besides the fact that we're charging you twice for it in terms of ingest. So you want to avoid that, of course, right? These are mutually exclusive. That's how you want to do this. You want to stay under 20 partitions. This is not a hard limit. The actual hard limit is 50. We want to stay under 20. Vast majority of customers stays under 10. But anywhere, if you're ending up with 33, that's fine too. That's not the end of the world. 50 is the hard limit. Next number is sort of, and that plays to the number of it. We want to ideally stay between 1% and 30% of your total volume. And the reason is if you have partitions that are much larger than 30% of your total volume, at least searching those partitions will not benefit much from the partitions because it's a huge index containing most of your data. Again, sometimes that's how it falls. I have customers that's all they have is the data from one Windows domain. There's no way of splitting that data up. That's just the way it is. So we have to live with it. If you have the option of divvying it up, right? Ideally, you have 10 indexes with each 10% of your data. Then you always ignore 90% when you're searching. That's perfect. That's obviously never how it's going to fall. That 1% is not a hard limit necessarily either, right? It's just a recommendation. The reason that's there is because if you create a lot of partitions that are 1% or less of your data, you're going to create too many partitions, right? There are edge cases if you have really important data sets that are really small, and you want to query them really fast, index them off, not the end of the world. Just don't do it with every single data set, right? And again, group the data that is searched together most often. And when I say search together, I mean within one search, right? If you have different use cases hitting different indexes, that's exactly what we want, right? But within one use case, we want to be able to, for the most part, find all the data that use case needs in one index. And that way, we hit that index only, ignore the rest of the data, and get a huge performance boost. So that's in terms of partitions. The way this works is very straightforward. If you have the permissions to actually edit them, it's the same with the collection. Not everybody does. You can go in here and you can edit or you can add one. In this case here, right? We have a partition called artifactory, and it's defined as source category artifactory star. Like we saw here, that includes all the data under the artifactory first component, right? And then the same, we have one for dev and one for prod, and then one for Tomcat. So that's just the way that these are defined here. Again, this is a dummy environment. The way you build this is the index name, and I'm not going to set this up, although it wouldn't hurt. My app one, source category, and I'm going to say prod, just to follow my example, my app one star. Now, all the data that's under here would fall into this index, and then you would click create. In this case, there's no data that matches this, so nothing will ever write in there. But that's how you split up the data. So it's pretty straightforward, right? End users or any users, any searches don't need to know about this, right? We transparently rewrite searches to these indexes as they fit. So what you call it at the end of the day, it doesn't really matter, right? So, and as I said, ultimately what we want to get at is the majority of your data being segregated off into its own index without any overlap, ideally at some volume around, between 1 and 30% of the total. That's how they're most effective. And that way, your data is indexed off in logical groups in terms of how you're using it. So that's, again, the main reason why we're doing this entire metadata scheme nomenclature is because we want to be able to do this. And this is a huge performance boost because the smaller the data set is that I have to go through, that the engine has to go through off the bat, the better the performance is going to be. And let's assume you have an index that contains 5% of your data. Every time you write a search that gets rewritten to that index, we ignore 95% of your data. That's a huge increase in performance, right? So that's why this is important. Any questions about these?
Nope, no
All right.
questions on the chat.
Okay. So these are our holistic feature, right? That's why not everybody has access to these. This should be, if you have different groups using the tool that are sort of separate from each other, when you design this, make sure, that it makes sense holistically for everybody. Again, that's the source categories will help with that. What a lot of customers will do is, they will say, so let's say you have 3 different teams using the tool. They're completely independent and they don't like to talk to each other, right? Everybody knows that. What you can say is the first 2 components are standardized across them, and what everybody does under here is up to them, right? And that's perfectly fine because we index at this level. So what the team for one app does under their stuff doesn't negatively or positively or in any way affect what other teams are doing, right? So, but if you have distinct teams using the tool on the high level, the first couple of components you need to agree on so you can effectively index this data off so there's no cross-contamination in terms of, one guy doing something that's going to hurt the performance of the other guy. That way everybody's working in their own subsets of data, and there's no harm done to other people. So it's a holistic feature. If you have distinct teams, at the minimum, settle on how you do the high level components. What everybody else does under them then is up to them. So similarly, next thing I want to talk about, field extraction rules. And this now, everything else we've talked about, at least in the last hour, sort of revolved around the same topic, which is, the source category and the metadata and why we want to do this. Field extraction rules are sort of a different topic. Field extraction rules are the best feature that we have, if you ask me, for a lot of reasons. I'll elaborate. If you're very, very new to Sumo, this, may sound, like something you wouldn't want to address immediately, but I would recommend adding as many field extraction rules as you can as soon as possible for a lot of reasons. So what are field extraction rules? First and foremost, let's look at what these actually do. Field extraction rules apply extraction logic for a data set at the time that data set is getting ingested. That's as opposed to running it when a search is run, right? So for those of you who have already run Sumo searches, right? Here I have an example. I'm looking at Tomcat access data, and I have two parse operators going here. One that extracts, and I'm not going into detail as to what all of this means. The next session in this trilogy will go into more detail about what this all means. But here I'm extracting the source IP address from this Tomcat access log, and here I'm extracting the method, the URL, the status code, and the size, right? And I run this, and I'm applying this extraction logic at the time of the search running. So search runtime. Field extraction rules are rules that allow us to apply these when data is ingested. So why would we want to do that? For one, the performance of the searches increases because every operation you don't have to do at search runtime is a win, right? Less work for the engine to do when searches are running means the searches are going to run faster. So that's one thing. In most use cases, my take is that this will be negligible or you won't notice. But the biggest benefits, and that's why I say these are the best, this is the best feature that we have, is for one, it standardizes field names across your organization. Different people are not going to spell source IP different ways. You have 6 different people and 6 different spellings of the word source IP floating around in your searches. That no longer happens because it's extracted once, everybody can use it. Standardizes field names, makes it easier to share and collaborate on content, right? So that's one thing. Second thing, it simplifies the searches. The parse expressions that we just looked at, or parsing in general, is sort of the biggest hurdle of entry into the tool. If you don't have to parse anymore because it's already done for you, right? Then that makes these searches simpler to write, simpler to read. It takes off a lot of the complexity that people normally have trouble adopting. Not everybody does regexes all day long, right? That's the best reason, or the most important reason why we want to use these, because while we have to put in some upfront effort to put them in, once they're in, everybody can take advantage of them and doesn't have to think about the parsing and the extraction logic and the regexes anymore, because not everybody wants to do that all day. So that's the reasons we want to do these. There's a couple of things I would consider when building them, and I'll show you how to build one. It's super simple. Build specific rules that are simple. There's some people that try to build rules that are all-encompassing, right, and do all this magic and are super complex. I would stay away from that. They're hard to debug. They at some point will fail, and it's going to take you 3 hours to figure out where. Build simple, very specific rules. With specific, I mean they're targeted to a very specific data set. As an example, if you have Apache access logs for 2 different applications, right? While the format may be the same right now, right? Build one rule for each data set. And the reason is the one app team may decide to add another field to their Apache log, and then it's going to break the rule for that data. If you build these very specifically for very specific data sets and they're simple, then there's 2 things that we'll do, right? One, they're easy to understand and easy to debug should something break, because on the logging something changed, right? And for 2, the amount of risk you're introducing by making them very specific is little, because they only touch very small data sets. So if they break, only very small data sets are affected. If you build these large, all-encompassing rules, if something breaks in there, potentially a lot of your data may be affected. So we want to stay simple and stay specific. Second, we want to make sure that we test these, right? And the reason we want to make sure that we test these is because when people start relying on their output, we want to make sure that they're doing everything that we think they're doing, right? I'll show you in a minute what I mean with that. So last but not least, there's currently a 50 rule 200 field limit. We can have that increased for you. You just have to ask. and then it gets increased to whatever. This sounds like little, but it's going to take you a while to get there. These are distinct field names, not total. And we have it planned to remove those limits entirely. So I'm not entirely sure when that's supposed to arrive, but that's at some point, those limits will no longer apply at all. And then not all operators that we have are supported in these rules. These rules can be used to tag data and create fields. It doesn't have to be all parse. But for now, let's focus on the parse. So if I run a search against this Tomcat access data, I can tell by just running this search that there's no field extraction rule that applies to this. And I can tell this because over here is what we call the field browser. This shows me for the data I'm bringing back which fields are available as individual fields. So we always have the raw message, right? But these fields are always available. These are always there. These are just Sumo metadata. These fields are always there, with or without rule, right? If I run the same thing against the Apache data without doing any extraction, I can see that there is the same fields, again, metadata, always there, but there's others. The method, the refer, the size, and this is here, right? These, and because I'm not doing any extracting here, I know that there's a field extraction rule that's doing this for me. And I can go into field extractions, and I can see, all right, what matches the scope Apache access? That's this one. This is the parse logic that is applying to this, right? And if I click on here, it will just open this data set and show me the parse logic if I wanted to debug it or whatever, right? So I can see this has just two parse operations going on. Both are regex. This one gets the IP address, and this other one gets the method, the status, the size, the refer, and the user agent out of here, right? So that rule is already in place. So for the Apache data, I don't need to extract those when I want to use it. I can just run searches and start using these fields for aggregations or whatever else. In the Tomcat case, I can't do that yet because I don't have a rule. So if I wanted to put a rule in place, I'm just going to write my parse expressions and run this. And you can see it's extracting this data. So what I mean when I say we want to test these, a lot of times what you'll find, even with logs that you think are structured and homogeneous, you'll find that they're actually not. There's slight differences in them that throw off these parse expressions. So you want to make sure that you understand that, right? Every parse expression that you run acts as a filter, meaning no messages that don't match this actually stay in the result set, right? And you can test this very easily by seeing here where is empty and then pick the source IP. There will be no values returned because this acts as a filter. So whenever there's a message that we can't extract the source IP, we drop the message from the result set. That's sometimes desirable and sometimes it's not. In order to test that a field extraction rule does what it's supposed to do, I can add the word no drop. That tells the parse expression to try to extract the IP address, and if it can't, not drop the message, keep it in anyway, right? And then I can run this, and then I can do again, where is empty IP address? Now in this case, that's telling me all of the messages in this data set, I'm able to extract the IP address, right? Because there's no empty value here. Just to show you what this looks like, if I go here and don't only do access logs, but include the Tomcat error logs as well, assuming there are any. There are. Now you can see I'm getting some where the source IP is empty, and that's because these are garbage collection logs, right? These don't contain an IP address because they're GC logs. So I just want to make sure that when I'm building this, in this case, I'm okay with it. This is not a log I care about for this field extraction rule, right? But I want to make sure I understand which messages that this would be dropping and which messages it would be not by using no drop, and then any field I'm extracting I can say where is empty field name, and that'll show me if there is anything here that's not being extracted. In this case, it's for all these GC messages, which makes sense. They don't contain an IP address, right? And after I'm done testing, I'm just going to say, okay, so I'm good with this. It's extracting everything I wanted to extract. Now let's add this as a rule. And I'm going to go back here and be more specific as to my own best practice. I'm just going to copy this. I'm going to go to field extractions. I'm going to say add. I'm going to call it Tomcast access. I guess the name is only relevant for finding it later again to edit it or whatever. Otherwise, it has no relevance. And then I'm just going to copy this thing I just copied. I'm going to paste it in both of these. From the scope part, I'm going to remove the parse expressions. And from the parse part, I'm going to remove the scope. And both of these combined are the make up the rule. Now I can click add, and now this rule is in place. Now this rule will only work going forward, but going forward, every message that comes in from Tomcat Access will have the IP address and these other fields extracted from it. Most important, very important feature to drive adoption, especially with users who may not be super technical, right? Because it removes the complexity of parsing entirely if you are extracting all the fields that they care about in these rules. Plus, it improves the performance and it standardizes the field names. All right, let's go. I know we're running up on time here, so let's talk about one other thing, and then we can hopefully have time for some questions. Last thing I want to talk about real quickly, scheduled views. Partitions and field extraction rules, as I already said, are holistic features. There's no willy-nilly going in there and messing with it because you can affect other people's stuff. Scheduled views are sort of not like that. Scheduled views, just to the definition, they're copies of subsets of your data. Think a relational database materialized view. They're copies of the data. So if you create a scheduled view that's not awesome, at least there's no impact to other people, right? Because it's a copy, it doesn't affect the raw data or the base configuration. So scheduled views are a performance feature, and they fulfill two use cases primarily. The vast majority of them are going to be use cases where you have long-term trending needs for some sort of aggregate. Let's say, somebody's is asking you for a 3-month, let's use a compliance use case. Somebody says this regularly. Show me everybody that logged into the Windows domain or to a certain host over the last 3 months, right? Obviously, you could search the raw data and pull it from there. Not going to be the fastest horse in the race because it's a lot of raw data for 3 months. So you create a view that pulls those logins out of that large amount of other events that are in there and writes them off to this view as a copy. That view is going to be very small because it only contains a small subset of the total data. And that way you can quickly retrieve, it's indexed by itself, right? And it's a small index. And that way you can quickly retrieve that data set from there. We typically recommend a selectivity of at least 1 to 10,000, meaning one message in the view, or one row in the view, I should say, is comprised in the aggregate scenario of 10,000 raw messages, right? Or for every 10,000 raw messages, only one makes it into the view if you write raw data to it, right? So it's highly selective. It finds small data sets within larger data sets and writes them off to this own index for quick retrieval. So this could be aggregates, this could be needle in the haystack type thing where you have very important messages that are hidden within a large amount of not so important messages, and you need the ability to quickly find them. Writing them off to a view is the way to go. So the views update themselves. The service will do it for you. Roughly once a minute, it will take the data that came in since the last time it wrote, do the aggregation or the filtering, and write to the view. This is one of the few features in Sumo that allows you to backfill. So if you can create a view on already ingested data, and you can do that because it's a copy, right? You can go back as far as your retention period will allow. When you're searching data from a view, you will use you use underscore view equals and then the view name. I can show you one that's there in a second and show you what that looks like. Because they're copies and we index them, they count against your volume. If you use them the right way, that will be so minimal that you probably won't care because the benefit will far outweigh the volume they generate. That's why we want this selectivity, not only because that way they perform faster, but also because they generate very little volume. There's customers that have dozens of these and they generate barely 1% of the total volume, but the benefit of having them is so large that the 1% is no problem, right? Or even if it's 2 or 3%. You can view views that you have here. So here's an example where we have artifactory logins, right? So basically we're picking out certain messages from the artifactory logs and writing into this view. This is similar to the use case I just had, right? Instead of having to look through large amounts of artifactory data to find the logins for the past 3 months, I can go to this view. It contains nothing other than logins, right? And it's just very small, and I can pull the data. And if you want to search in this, the way this would look is basically like this: underscore view artifactory logins. Ironically, in this one, there aren't any. Yeah, there are. And apparently I logged in here. So you can see, and the only fields that are in here are the IP, the actual login status, if it worked or not, and then the user who did it. So that's it from me. Any questions? I'm happy to stay on a few minutes and answer some if anybody has any.
Thanks, Olaf. Any questions? Feel free to put them on the chat. In the meantime, Olaf, I'm going to probably grab control from you here.
I can give it back to you. I don't know if I can.
Oh, I think I just took it.
Okay.
Good. Any questions from those on the phone? All right. So, Olaf, thank you so much for everything you went through. We saw that we can ingest any types of logs, whether structured and unstructured data. Olaf walked you through the different deployment options and talking about perhaps a hybrid strategy that might work for your environment. We made an emphasis on a robust naming convention for your metadata, specifically on that source category field, because you saw how it's important it becomes for other items. And then lastly, we talked about optimization, so taking advantage of field extraction rules, schedule views, and partitions. So if I were to extract a call to action here for you guys for the next few weeks, the first one is starting to set up a deployment option or a hybrid option that best fits your environment. Ensure if you've already ingested data, ensure that you go back and you develop a robust source category naming convention. I will send you these slides. I will send you the recording. There are in the slides, there are some links to other blogs that Olaf has written about what are good source categories and bad source categories. So you definitely want to get on top of this and get a good naming convention right off the bat. And then the third one is from a performance optimization standpoint, at the very least, as Olaf pointed out numerous times, set up your field extraction rules. Set up as many field extraction rules you can for your popular data sources. Make them, as he said, make them specific. If you have different source systems, set it on for those source systems. But your field extraction rules are going to really help with the adoption of this tool for all your users out there. All right, so I know there are no questions, or at least none have come in. I'll just take this moment to let you know that there's a few resources for you. For one, if you go to sumologic.com/training, there's the next two sessions that are part of the trilogy that this one is part of. The documentation can be found at help.sumologic.com. Also, we have a community. We call it Sumo Dojo, but you can search, you can post into our community. We have two channels. One is if you go to community.sumologic.com, that's our forums, and you can post in there. But we also have a Slack channel. So for those of you who do use Slack, you can go in there and post questions. And this gets viewed not only by us at Sumo, but by other users as well, so they can help you out. Obviously, you can open support cases at support.sumologic.com. But last and not least, always looking to improve the product. So if you have an idea of features that you want to let us know about, go to our ideas portal and let us know about these. Again, I'll send these slides, I'll send a recording, and if you have any other questions, feel free to hit us through any of those channels, or I'm more than happy to take your questions and find answers for you. Mario at sumologic.com. Thank you, Olaf, and thank you everybody for attending. Appreciate your help. Have a great day.